Okay, guys, we are looking at solving quadratics, but now by using factoring. And remember that quadratics means that they include an x squared. So this question is definitely quadratic. It has x squared. And just to kind of show you why we even do factoring, there's this issue where if I try and solve this equation with inverses, like we have solved everything else all year long, we end up, okay, we get to this point. When we did it in class, everybody typically wanted to divide by -3 at this point. The problem is you have to divide this entire side by -3. So this side works out just fine at -6. This part works out nice and clean. -3x divided by -3 becomes a positive x. But when you divide x squared by -3, it actually makes x squared over -3. So even though you've kind of simplified one piece of it, you've made another piece of it really disgusting, and you haven't actually canceled anything out that would help you actually isolate x. And so you get to this point where then they wanted to subtract the x. So if I subtract the x, I end up with x squared over -3 equals -6 minus x doesn't do anything. It just stays -6 minus x. And so you figure out pretty darn quick that as you're moving things around, it's just not ever going to really turn into anything even remotely looking like an answer. So we said, okay, inverses won't work. That's how we have solved every equation up till now, is with inverses. And now our inverse operations are not isolating x in this situation. Now, stay with me. It's going to feel like we completely change topics, but I promise it will all come back around. So if I have 3 times some mystery number and it equals 0, in algebra, you'd typically see that as a letter, like 3 times x, but I'm just going to go super elementary here. If 3 times something has to equal 0, the missing piece has to be 0, right? I mean, that has to be a 0. It's the only way you can multiply 2 factors and end up with an answer of 0. So you could say, okay, so x equals 0. Well, if I say I have 2 unknown values that multiply to equal 0, I don't know either of them, but I know that when I multiply them together, they equal 0. What does that tell me? Well, either that one has to be a 0 or that one has to be a 0, right? Like, it's the only way you can multiply and end up with a 0 is if there's a 0 in the multiplication problem. This is kind of a big deal in math. It's called the zero product property. And it's something that you guys know from elementary school, and it says if A times B equals 0. So if you have 2 unknown pieces that multiply together to equal 0, then one of the factors must equal 0. So in other words, we could kind of write that mathematically as A equals 0 or B has to equal 0. One of those two things has to be the case. This is a really useful property as we start getting into nastier and more difficult equations, and I'm going to show you why, but it's not going to make sense right off the bat. So if I start with a very easy 4 times x minus 2 equals 0. So 4 times something equals 0. Well, the only way that I can multiply 4 and make it end up at a 0 is if this equals 0. So then you've got to kind of ask yourself as we're solving this equation, well, what does x have to be so that I get a 0 right here? And most of you are able to figure out that, oh, x has to be a positive 2. If I plug in a positive 2, 2 minus 2 is 0, and 0 times 4 makes a 0. It's the only value that works. A lot of times people want to say that 0 works. They want to say, oh, so if it equals 0, x has to be 0. Well, if I plug in a 0 for x and really kind of look at what's happening there, 0 minus 2 is -2, and 4 times -2 is actually negative 8. So that is not correct. That's why x isn't 0. X is 2, so that when I plug a 2 in there, it makes a 0, okay? So just kind of be aware of that. So if I mix it up a little bit and say, okay, well, x minus 6 times x plus 3 equals 0. This one was a little simplified because the 4 wasn't going to give you a 0, right? This had to be a 0. Well, here I have two unknown pieces being multiplied together. So I know either this one has to give me a 0, so 0 times whatever equals 0, or the back one has to be a 0, so that whatever times 0 equals 0. I'm saying 0 a whole lot. So if I need this to be a 0, x is going to have to be 6, okay? Because 6 minus 6 will become 0, and then it really doesn't matter what happens over here. So if you do 6 plus 3, you get 9. It doesn't matter because 9 times, well, that's going to be a 0, is going to make a 0. But that's not the only option that will make this thing equal 0. I could also say, well, what if the back part gave me the 0? So what if x was negative 3? Well, negative 3 plus 3 would be 0. And then honestly, it doesn't even matter what happens in this first factor because negative 3 minus 6 is negative 9, but it's going to get multiplied by 0 anyway. So we kind of are seeing a little bit of a connection where these are having two answers, just like quadratics had two answers, okay? So if I go with x plus 5 times x minus 2 equals 0, again, you're just looking for what are the values of x that will make this thing equal a 0. And so you end up with, well, a negative 5 would make the first part 0 out, and a positive 2 would make the back part 0 out. And if either of those become a 0, then the whole equation equals 0. And so those both count as solutions, okay? Totally works. So things you need to be aware of. These must, for this whole property little trick to work, one, they have to equal 0. Okay, it's not the 50 product property, it's not the 35 product property, it's the 0 product property. 0 special because it's really, really like specific in how you can make something equal 0. And then the second thing has to do with this word product. Okay, it has to be a multiplication of two factors. And it will typically always be two factors. I put the star there because it will occasionally be three factors, but it's going to most all the time end up being two factors, okay? So you got to have equals 0, has to be multiplication. So what happens when my factors get just a little bit harder? X plus 2 times 3x minus 1 equals 0. I encourage you to pause it, kind of see if you can figure out, okay, what's going to make this factor become 0? What's going to make this factor become 0? The first one's really easy. The first one you get pretty quick at recognizing, okay, negative 2 plus 2 cancels out. This one you're going to have to think a little bit. I need a number that when I multiply it by 3 and then subtract 1, it becomes 0. And with a little bit of thought, you start to figure out that it is 1/3. 3 times a third is 1. Minus 1 becomes the 0 that you need. So that's a little bit different. Let's look at another one kind of similar to that. 2x plus 5 times x minus 4 equals 0. Again, this time the second half is the easy part. So I know the second half of my answer is going to be positive 4, so something or 4. And pause it for a minute, see if you can figure out what has to go right here so that when you double it and then add 5, you end up at 0. The answer is negative 2.5, okay? Some people got really vocal in class about the fact that no, it's not, it's negative 5/2. This is useful because the fraction shows you a little bit of a pattern. So look at those two problems and see if you see any kind of relationship between the factor and the solution that it gave. The factor and the solution that it gave. Okay, let's see if this one helps you see it a little bit more clearly. 3x minus 4 times 6x plus 1 equals 0. Again, I kind of haven't done a good job of this, but it equals 0, so that's totally good. And it is definitely the multiplication of factors, okay? So I'm going to figure out, okay, what does x have to be to make 3 times that number minus 4 cancel out? What does x have to be so that 6 times that number plus 1 cancels out? Pause it if you need to, but you end up with x equals positive 4/3 or negative 1/6. Again, if you didn't see the pattern in the last two examples, see if you notice the relationship here, okay? It's hopefully pretty clear. You take the opposite sign, okay, so negative 4 becomes positive 4, positive 1 becomes negative 1. Then the back number equals the numerator. The coefficient, right, the number in front of x equals the denominator. All right, and you'll see some more examples in the second video, but that's kind of the basic process. Is if it's a tricky factor, then you just take the opposite of 4, positive 4 over 3. Negative 1 to do the opposite over 6. And that's kind of the shortcut way to do the tricky ones, okay?